Okay, welcome to ISD 250, which is system analysis and designing. Sorry, let me just work on something. I don't want this to get in the middle of my presentation. Okay, so this is system analysis and designing, and today we are looking at we are uh, doing our unit 4, and unit 4 is basically on use cases. So the content for this particular unit, we'll introduce what use cases are, and then we'll look at the elements of use case. Then we'll look at alternative use case formats that you can use to present your use cases. Then we'll look at what use cases are and the functional requirements of use cases. Sorry, let me just get a pen. Then after that, we'll look at use cases and the functional requirements. Then we'll look at use cases and testing. Then finally, we'll build some use cases just to demonstrate what we've captured. So what are use cases? We are saying a use case is a tool used in system analysis to describe how users interact with a system. So we are saying it's a tool. Sorry. Okay, what have I done? So we are saying it's a tool. My pen is not working. Okay. Fortunately, my pen is not working, but I wanted to highlight the word tool. It's a tool used in system analysis to describe how users interact with the system and how they tend to achieve a specific goal. So basically, it provides some form of a structured way to capture functional requirements by detailing user actions and system responses. So that's how a use case basically looks like. On the left side of your screen, you have an actor. On the right side of your screen, you also have an actor. So on the left, you have a primary actor. Then on the right, you have a secondary actor. So a primary actor, basically, this is the normal user that interacts with a system. It can be you, it can be me. Then on the other side, these are other actors, such as maybe an API that the system is connected to, a database, etc., etc. Those also speak under secondary actors. So in the rectangle shape that we have there, what we have is the particular system that the actors are interacting with. Then the oval shaped and in dark blue shade, those are the actual use cases. So the use cases, in simple terms, I can even say these are the requirements that the system has. And by requirements, we are looking at the functional requirements. Remember, we have the technical requirements, the functional requirements, and the non-functional requirements. But at this point, we are looking at the functional requirements. Things like the system should allow a user to do registration. Those are functional requirements. And then we'll look at this in detail. I just wanted to show you an abstract of what it is, so that as we are speaking and as we are going through this particular unit, you can know what we are talking about. So what are the key characteristics that a use case has? One, we are saying it represents a specific function or task within a system. So one of that other thing, it represents a specific function. This function can just be even login. It is a specific function in the system. So the characteristic of a use case, we are saying it represents a specific function or task within a system. Secondly, it focuses on interactions that occur or happen between actors. These actors can be users or external systems, like I said, users, fall on the primary actors, then external systems fall on what we are referring to as secondary actors. So use cases focus on interactions between actors who can be users or external systems and the system itself. Use cases define both normal as well as alternative workflow. What do we mean is there are certain things, if a process has to be conducted, there is a normal way a process goes. For example, if you're looking at student registration, there is a normal process that student registration actually does take. But apart from that normal process that we understand, there can be alternatives. Maybe something hasn't gone the way it should be. A student has made a payment at the bank, but that payment doesn't come through. So apart from that normal process that a student should go through, there can be an alternative. If a payment is not coming through after payment at the bank, probably some follow-ups should be made with certain officers, either through finance or you go to the actual bank. That becomes an alternative. So these use cases should not just provide you with the right or the correct way of doing things. It should also provide alternatives. If this doesn't happen, this is the alternative workflow that should actually be undertaken. Apart from that, we are saying it helps in system design. Use cases will help the person that is designing a system to understand the requirement of the system. It will also help the developers as they are developing the system to understand the functions that the system will actually provide. Apart from that, the actual person that is going to do the testing, it will help them with the testing process. And they'll be able to check, is this being done in the system? No. Is this being done in the system? Yes. So the person who is going to do the testing as well will definitely need to follow through and use a use case to actually understand the functions or the interactions that the user expects with the system. So basically, those are the characteristics of a use case. Let's look at the purpose of use case analysis. Why do we need to use use case in system analysis and design? One, it helps us define system behavior from a user's perspective, because it is the user that will interact with the system. So this has to capture exactly what the user will be going through as they interact with the system on a day-to-day basis. So this helps us to go back to a user and ask them to say, is this what you are expecting to achieve from the system as you are working with it? So it defines the system behavior based on the user's perspective. Apart from that, it identifies key interactions between the user and the system. So as you are reviewing, as you present this use case to the users after capturing the requirements, they can actually tell you there's a step that has been missed. There is this interaction that we expect between the system and the user. It also helps in understanding functional requirements, because after you do the presentation, after you put everything into context, this is a system, this is a user, this is a secondary user or an actor. These are the interactions that we expect. These are the relationships that we expect. If something is not captured, then it can actually be brought out to say this particular function has been left out. So these are some of the things that use case analysis does help us. Again, we are saying it assists in designing test cases for validation. Remember, you need to validate your requirements. You need your users to agree to say, this is what we gave you. These are the requirements that we've given you. So that when the development starts, the user won't come and say, this needs to be added, whereby it drives you to having that scope creep that we have been talking about. Let's look at an example of a use case. And this example of a use case is based on an online banking system. And the particular area of interest is fund transfer. So when you're looking at this example of an online banking system, and remember we were saying a use case can be based on just a small function of a system or the entire system. But this time around, we are focused on you using an online banking system, but with a focus of transferring some funds. So if you have to transfer some funds, let's look at the entire use case. So we'll start with the actor. One of the actors that we expect in this particular system is a bank customer. And this bank customer is playing a role of a primary actor, which means they will be on the left side of a use case. Apart from that, you need to have the use case name. Remember in that box, we are where we needed to put the system name. So the system name here, we are just dealing with a small component of this particular system, which is transfer funds. So that is what we are putting there. What are we trying to achieve? Because for every action that you do, for every interaction that you do with a system, there should be an end goal. And for us, the end goal here is to allow a customer to transfer funds between accounts. So you want a customer to transfer funds from their account to another account. So remember, since we are only looking at a small function or a small portion of this system, there are certain things that we should assume have happened for us to reach at a point where we can actually transfer. One of those things that we can assume is by now this person has logged in. By now this person has done A, B, and C. Now they are at a page in the system where they need to transfer. So for every use case, especially if you are not dealing with the entire system, you need to have some form of preconditions. Some preconditions. So the precondition that we have here is the customer must be logged into their account. Otherwise, they won't be able to transact. But if we were not just limited on the fund transfer component of the system, we would have included all those things: login, failed login, success. But at this point, our use case is trying to capture the requirements surrounding fund transfer. So some of the things that you should assume have happened, or some preconditions, is the customer must be logged into their account. How do you propose this the fund transfer function should be? The main flow of this activities: one, the customer needs to select, presuming or assuming there's a button called transfer fund. So the customer needs to click on click or select the transfer fund option, which you can actually capture it as a use case. Secondly, the system then displays a form to enter details, and these details can be things such as the recipient account number, the amount, etc., etc. Apart from that, the customer may need to enter details and their details and submit their request. The system needs to validate the transaction and deduct the amount. So the system will check this amount you're trying to transfer. Do you have it in your account? If you don't have it, it won't be successful. If you have it, then it has to be successful and the amount has to be deducted. After that, the system needs to confirm that the transfer and has gone through, and it needs to provide you with some form of a transaction ID, because this is a transaction ID that you can refer to say, I made this transaction, it hasn't gone through, or it hasn't been credited to the other person or debited, things like that. Remember where I was saying there's always that normal process, but what if something along the way doesn't happen? For example, if the system, as it is trying to validate if you have that amount, checks that you don't have that amount, then an alternative flow needs to be undertaken, of which, for example, if there are insufficient funds, the system can display an error message and prevent the transaction. If the account detail where you're trying to send to is invalid, again, the system may get to notify the user and prompt for correction. So regardless of you having this main flow of this is how the use case is, or this is how a transaction will be, this is how the process flow is, as you are capturing requirements, you also need to bear in mind there are also alternatives. So if those alternatives were not captured, maybe this is the best time as you are presenting your use case to actually capture that, because so most of these processes always come with some form of alternative. Let's just look at some elements that a use case has. One, a use case typically consists of several components. The first one being an actor, which I've spoken about. The actor, this is a user or system that interacts with the system. When we say system, again, we are saying this is the user or system. By system, this system, we are looking at the secondary actor. Remember, on the left-hand side, there's a primary actor who is a user, a normal user. On the right-hand side, there is a secondary user who can be a system or can be an API that your main system is connected to, or it can be another module that the module that you are looking at is connected to. So these actors can be customers, they can be an administrator, this can be an external API, etc., etc. Apart from an actor, you have a use case name. So the use case name, like we had in the previous slide where we're saying fund transfer, this has to be clear. It has to be descriptive. So you need to have things like process loan application as a title of that system. Remember, there was this box. How do I go fast to that box? How do I go back to that box? Remember, on top there, we have system name. That's where we are saying that name there, where we're saying system name, you need to give it the name of the system or the name of the module that you are looking at. It can be fund transfer. So you need to give it, that system name has to be something that is meaningful. Okay. So we're saying you need to have a use case name, and it should be clear. It should be descriptive. It should be a descriptive title for the process. For example, it should be process loan application. Then you need to have what you want to achieve. You need to have a goal. So the goal is the objective that the actor wants to achieve as they're interacting with this system. So you can't just want to interact with this system. So it can be you want to transfer funds. It can be, so the goal has to be there. You may be interested in doing your registration, printing out your exam slip. So that is a goal. So for each use case, there should be a primary goal. Apart from that, remember I said there should be some preconditions, especially if you're just looking at a smaller component of the system. Preconditions can be things like logging in, because you don't just assume someone will land to the registration page of a system. They need to have some preconditions. For you to reach to the registration, you need to have paid this much. You need to have, so those things also need to be taken note of. Apart from that, some other elements, you remember there's that workflow. So there's supposed to be some workflow, and the workflow is a step-by-step. A workflow is a step-by-step description of the typical scenario. There are also, so this is where you explain exactly what the use case will be like. From doing this, you need to do this, doing that. Then remember, we said everything that you provide, there should be some form of alternative. So there can be some alternatives where if you started with this, you may, if something doesn't work out, there may be an alternative process that you need to actually undertake. After that, you expect some form of post conditions, because this may not just be a full system. So you may just be looking at a portion of the system. So after that, what you expect, oh, the balance should have changed, things like that should have changed. Your registration status should have moved from not registered to registered, etc., etc. So there should also be, apart from preconditions, there should also be some form of post conditions. And there should be some exceptions of some sort in terms of errors and unexpected conditions that may be handled by the system. Remember, I said we also have some alternative, from that diagram that I showed you, we also have some alternative ways in which a use case can be presented. So a use case can be documented in different formats depending on the project needs. One of the ways in which a use case can be documented is through what we call informal use cases. Secondly, is through what we call structured use cases. And third, it's through what we call graphical use cases or UML diagrams. The one that I showed you is C, graphical use cases, where you're able to see an actor and all those boxes. That's a graphical use case or UML diagram. But we also have informal use cases as well as structured use cases. So let's start with the first one, which is an informal use case. So an informal use case basically is a simple description written in plain language. So instead of you having that diagram, all you have is basically some plain language where you're explaining the requirements. So you're explaining the requirements. If a user does this, secondly, the user does this, thirdly, then they are done with their goal. So basically, when you're using informal use cases, you are just basically using plain language, no drawings. All you're doing is you are writing the steps, how they should be for you to accomplish a task. This is best used in early stages as you are having discussions with the users where you just capture those and you present back, is this what you mean? And this is what now builds into those UML diagrams, because you've captured this in plain language and you've presented back, is this what you're expecting? And if that's what they're expecting, then you tend to put it into some form of a UML or graphical use case. An example, you can just write something like a customer selects an item and completes the transaction. But this same one, you can actually have it in a UML use case diagram where, since we have a customer there, you can have an actor on the left who is a customer, and you can have a system, and within there, you can have a use case, that oval diagram saying purchase. So a customer can interact with a system to purchase, and there may be other alternatives in case the customer fails to purchase. Secondly, we have structured use cases. This is where we're saying use cases in this type of alternative use case format, they use a predefined format with steps and actors. This clearly separates normal as well as alternative workflows, like the one that I showed you, where this one is a structured one. I showed you one. Let me just look. This one is a structured one where you have everything clearly written. It's structured. You have your actor, you have your use case name, you have your goal, your preconditions, the main flow, the alternative. That's a structured approach. So a structured use case uses a predefined format with steps and actors. It clearly separates the normal and the alternative workflows. An example is a table listing each step in a transaction process, like the way we listed there. From this in the normal, you go to this, you go to this, and in the alternative, this is what you do. And thirdly, the one that we've been looking at, which is a graphical use case. So this uses UML or Unified Modeling Language to visually represent actors and interactions. An example, a use case diagram for an ATM. So for an ATM, in that rectangle, you expect the system name to be probably ATM system. And in an ATM system, the use cases that you expect or the functions that you expect could be withdraw, deposit. Those are the two use cases that you expect. So the user may interact with the ATM system by withdrawing or by depositing. So those are the two use cases. And you can have also some form of preconditions such as logging in, because At that point, maybe we are not looking at the entire ATM system. So you can have such preconditions, and you can have certain post conditions such as new balance, etc., etc. So use cases play a crucial role in defining functional requirements, like I've put it, which specify what the system must do. So functional requirements specify what the system must do, and use cases do play a very crucial role in defining that, because it's through that you'll be able to tell, say, this has worked out or it hasn't worked out. Use cases relate to functional requirements. Why? Because each use case corresponds to a functional requirement. So like I was saying, for an ATM, you can have a use case like withdraw. That's a functional requirement. You want this ATM system to help users withdraw their money. Another use case can be deposit, because you want this system, the ATM system, to help users deposit money. So each use case, when you draw use cases, each use case should correspond to at least a particular functional requirement that you had gathered through your informal use case setup. Apart from that, we are saying use cases describe system behavior as you expect it in real world scenarios. Withdraw. Withdraw, you expect it in a real world scenario because you know the process of withdrawing. Deposit, you will know it in a real world scenario. So use cases also help developers and testers to understand the expected outcomes. That's why you have post conditions. Those post conditions should speak to the developers and the testers on what should happen. So after someone withdraws, a post condition should be the balance changes to minus what has been withdrawn. After a deposit, the balance changes to plus what has been deposited. So examples, we are saying a functional requirement, the system must allow users to reset passwords via email. So a use case can be reset password. So if you have a functional requirement like the system must allow users to reset password via email, the 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 sorry. Okay, just wanted to see if my voice was being recorded. So a function requirement, for example, maybe the system must allow users to reset passwords via email. So if you are turning that into a use case, basically maybe in that overall thing, because you can't write a sentence, all you may write is reset password. So that use case basically captures the entire sentence where we're saying the system must allow users to reset passwords via email. So, like I was saying, you have a user requirement of the system must allow users to reset passwords via email. If you have to relate that to a use case, we are saying the user initiates a password reset, receives an email, and resets the password. So in that use case, what you're expecting are things like the user will initiate a password reset. Then the system will respond back by sending an email, and the user again responds by resetting that password. How do we use use cases in testing? We are saying use cases serve as the foundation for creating test cases that validate functionality. Because if you present to a user will be able to tell if what they've been expecting from the system has been met or it hasn't been met. So the use cases serve as the foundation for creating test cases that validate functionality. So as you take through your users, they should be able to tell you, to say, things are as they expect them or things are not as they expect them. Use cases in testing help in defining test scenarios that mirror real-world interaction. So as you present those use cases, a tester can actually use that use case and proceed with their test. So use cases also ensure that all possible user actions, including edge cases, are tested. So you go through all the use cases in that have been given in that UML diagram and ensure the system that has been developed is actually doing all those things. Apart from that, use cases help to improve requirement validation by confirming expected system behavior. So if there is a particular use case that has been depicted in the UML diagram, these testers will be able to see if the post conditions are as they are depicted in the use case. For example, for login use case, test cases might include a valid login, because if you are trying to present a use case to do with login, you don't just expect when someone pushes in their username and their password, then they should be able to log in. There are other alternatives. So for a login use case, the test case might include valid login, where you expect now the username and the password should be correct. Then there can be an alternative where the login, where there's an invalid password. So there, what you expect is an error message being displayed to say, and at most, the error message, so that it is not obvious. It won't just say your password is not correct. It will say either your password or your username is not correct. Why? Because you don't want to be obvious. What if this person is trying to hack your system? You don't want to be obvious by telling them to say it's the password which is correct, which is not correct. The username is correct. So you are not even presenting to them which is valid and which is not. So you just tell them either your password or your username is not correct. Okay? And then apart from that, there is that account lockout. So after multiple failed attempts, there can be options of the account being locked out. So all those things can play a part or can be included in a use case that has to do with logging into a system. Last but not the least, we look at use cases, at building use cases. So the steps to building a use case are as follows. One, you need to identify the actors. That is, you need to define the users who be on the left, that is the primary actors, and external systems that will be interacting with the system, that is your secondary actors on the right-hand side of your system. Apart from that, you need to define use case goals by clarifying the objectives of each actor. Thirdly, you need to outline the main workflow. What is the correct process of how things should be? So you need to describe the normal step-by-step interaction. And secondly, fourth, you need to identify alternatives in case the main flow doesn't go as you expected. How should things operate? So you need to include variations such as errors as well as exceptions. Apart from that, you need to specify the preconditions, things that should be done in advance for one to land at that particular page of that particular function of the system, as well as the post conditions, that is things that should happen after that particular interaction has happened. Then last but not the least, you need to review and validate. Present to your users, is this what you're expecting? If certain things are not captured, then you should be able to highlight and say, okay, this has not been captured, and this is how it should be. Example, we've given an example there, building a use case for an online shopping checkout. So the actor in this scenario, if you are looking at a system which has to do with an online shopping checkout where you've bought things online and you want to check out. The actor should be a customer on the left. Then the goal, you want to complete a purchase. The main flow, what you expect there is the customer selects a product. The customer adds items to the cart. The customer proceeds to check out and enters shipping details and payment information. The customer confirms the order. So those are the things that you expect. But this is the main flow. There can be alternatives. So the alternative can be the payment fails. So you need to provide for this alternative of where the user is prompted to maybe re-enter the details or things like that. Apart from that, some item may be out of stock. As you are trying to buy, you are slow, someone has put it in their cart and they've bought. So that item is no longer there and you can be notified and redirected. That's an alternative as well. So this particular workflow that I've given in another video, I'll show you how to actually create such type of use cases. So I've given, this is a structured, remember we had that structured use case. So I've given this in a structured form. We now need to have another day or another tutorial where we'll actually look at how to actually create this now into a UML diagram. So basically, that's about it. And in conclusion, we are saying use case analysis is a powerful tool for capturing requirements, for designing system interactions, and for ensuring robust testing. So I will be able to share with you another video where we'll actually just see how you can go about in creating these use cases using uniform UML or graphical use cases. For today, this is where we are ending with our presentation, and have a good day.